prove that the gamma function of n is equal to minus infinity for n equals 0, minus 1, minus 2, minus 3, and so on. That is, the gamma function of a negative integer, and 0 are infinity. Let's start with 0. Recall that gamma of s is equal to x minus 1, gamma of x minus 1, and then gamma of s minus 1 is equal to gamma of s all over x minus 1. So this is what I have done. I have divided both sides by x minus 1. So let x be 1. Put s to be 1. I have gamma of 0, gamma of 1 over 0, which is equal to infinity. You can see for n equals 0. Now for n equal minus 1, similarly, put in here, when n is minus 1, when s is minus 1, when s is minus 1, no, when s is 0 rather, from here, I'm using this. When s is 0, I have gamma of minus 1 is equal to gamma of 0 over minus 1 will give me minus 2. But gamma of 0 is infinity, so this one will give me infinity. So if you go on like that, or let us use induction. Assume it is true for some negative k. Negative k means that is negative integers. So what am I trying to say is that it's negative of minus k, where k is positive, so negative k will now be negative. That is, assume it is true for some negative k. Now let's prove that it is true for negative minus k minus 1. What I have done here is I'm simply using the induction principle. I'm using induction to prove this. So this one will be equal to negative gamma of negative k all over negative k minus 1. So this one will also be equal to infinity. So that means that, so what we need to take note here is first gamma of n is infinity for n equals 0, minus 1, minus 2, and so on. That is the first thing we need to do. Now we want to do some other exercise, miscellaneous exercise. I have quite a number of exercises here we want to solve. Number 1 is saying if n is a positive integer, prove that prove that 2 raised to power n gamma of n plus 1 over 2 is equal to 1.3.5 till you get to 2n minus 1 root pi. That is the first thing we want to do. Solution. The first thing is we have to do this gamma of n plus 1 over 2. What will gamma of n plus 1 over 2 become? Don't forget, this is very important. Gamma of s equal s minus 1, gamma of s minus 1. This is highly important when you want to solve this type of question. So gamma of n plus 1 over 2 will be equal to, this one will be n plus 1 over 2 minus 1, which will give me n minus 1 over 2 gamma of n minus 1 over 2. That's what I'm going to have. So I'll continue this way. This one will be n minus 1 over 2, n minus 3 over 2, n minus 5 over 2, and it goes on like that. Since n is a positive integer, it will get to 1. No, when it continues to reduce like that, the time will come it will get to 1. And by the time it gets to 1, it will be 1 over 2 gamma of 1 over 2 by then. If you count how many of these brackets we have, it should be n brackets. So this one, if you find the LCM here, this one will be 2n minus 1 over 2. This one will be 2n minus 3 over 2. 2n minus 5 over 2. Till you get to 3 over 2 multiplied by 1 over 2. Gamma of 1 over 2 is square root of 5. So gamma of n plus 1 over 2 will be equal to, all the numerator will multiply themselves. That will be 2n minus 1, 2n minus 3, and on till you get to 3, till you get to 1. All over, all the denominators are 2, n times. You can check it. You can actually check it. This one will be n times. Because it is when you get to n, you know, when I subtracted 1, when I did n minus 1 over 2 minus 1, n plus 1 over 2 rather, minus 1, I got n minus 1 over 2. That is for only one bracket. But when I go to n bracket, that will be n plus 1 over 2 minus n. N minus n will give me 0, I will be left with 1 over 2. That's why I have gamma of 1 over 2 here. So they are n brackets. So that means 2 times 2 times 2 times 2 n times. It will be 2 raised to the power of n square root of 5. Let this 2 raised to the power n come to the other side. I have 2 raised to the power n, gamma of n plus 1 over 2 is equal to, then I decide to write from here 1 times 3 times, then up to this place. 1 multiplied by 3 multiplied by 5, down to this place, 2n minus 1 root 5. We are through with the first proof. Now come to the second one. Coming to the second one, let me write the second question on the board. The second one is saying that, with certain limitation, number 2, with certain limitations on the values of A, B, M, and N. Prove that with certain limitations, prove that integral from 0 to infinity, double integral from 0 to infinity of e raised to the power of minus as squared plus by squared minus as squared plus by squared s raised to the power 2n minus 1 y raised to the power 2n minus 1 ds dy is equal to gamma of n all over 4 raised to the power a raised to the power n b raised to the power n. That is what we have there. Solution. So, let me write the integral as we want to show this is equal to gamma of n, 4 raised to the power a raised to the power m, b raised to the power n. Integral from 0 to infinity. integral from 0 to infinity e raised to power minus ax squared plus by squared x raised to power 2m minus 1 y raised to power 2m. The truth of the matter is that I can actually separate this integral to obtain. This is what I mean by separating the integral. This can be written as 0 to infinity of e raised to power minus ax squared x raised to power 2m minus 1 ds multiplied by integral from 0 to infinity e raised to power minus by squared multiplied by y raised to power 2n minus 1 dy. As you can see what I have here, they are almost the same thing. Only the difference is just this is A, this is M, this is B, this is N. But they are same, they are together, they are the same thing. So the reason why I can separate it is because I can carry or I can group all variables of x together and all variables of y together. So now let's simplify this one. Let's simplify this. So let's simplify this. Integral from 0 to infinity of e raised to power minus ax squared x raised to power 2m minus 1 ds. So the first thing I will let was t. Let t be equal to ax squared. Make ax the subject of formula. X will be equal to t over a raised to the power of 1 over 2. Differentiate. ds is equal to 1 over a raised to power 1 over 2 multiplied by 1 over 2 t raised to power of minus 1 over 2. The t, when you differentiate, this is what you are going to obtain. This is what you are going to have. Now, when x is 0, t is 0, when x is infinity, t is infinity. So I will have integral from 0 to infinity of e raised to power minus t multiplied by, this is x. x is t over a raised to power of 1 over 2. Then it's now multiplying 2m minus 1 because this one is also at the power. Multiplied by ds. ds is 1 over 2a raised to power 1 over 2 t raised to the power of minus 1 over 2 dt. So this is integral from 0 to infinity e raised to power minus t. This is t over a raised to the power of m minus 1 over 2. 1 over 2 times 2m will give me m. 1 over 2 times minus 1 will give me minus 1 over 2. That is what this one will give me. Multiplied by 1 over 2 a raised to power 1 over 2 t raised to power minus 1 over 2 dt. So at the end of the day, this 1 over 2 will come out. Let it come out. 1 over 2 integral from 0 to infinity of e raised to power minus t multiplied by, this is t raised to the power of m minus 1 over 2. This is t raised to the power of m minus 1 over 2. But I have another t raised to power minus 1 over 2. When I use the law of indices, this one will be m minus power minus 1 over 2, 1 over 2. Then multiply by 1 over. This is a raised to the power of m minus 1 over 2. This is another a raised to power 1 over 2. Don't forget, these two beside it has been brought outside the integral. So this is a raised to power minus 1 over 2 plus 1 over 2 plus 1 over 2 dt. So I have So that I will have 1 over 2 integral from 0 to infinity of e raised to power minus t minus 1 over 2 minus 1 over 2 will give me minus 1. So that I have t raised to power n minus 1 multiplied by 1 over minus 1 over 2 plus 1 over 2 will give 0 multiplied by 1 over a raised to power n dt. Take the a raised to power m outside because it's also a constant. 1 over 2a raised to power m integral from 0 to infinity e raised to power minus t raised to power m minus 1 dt. And what do you notice? Notice that this is 1 over 2a raised to power m gamma of n. Since I have n minus 1 here, that will be gamma of n. So that is what I have. So similarly, I have done for only this one. This is what I have done. Similarly, I will do for integral from 0 to infinity of e raised to power minus by squared y raised to power 2n minus 1 dy. I don't need to solve for this one again because what I did here and what I have done here, they are the same. I just need to replace a with b, and n with n. So replace it here. This one will also be 1 over 2 raised to power 2b raised to power n gamma of n. So therefore, our final answer will be the multiplication of the two. Integral from 0 to infinity, integral from 0 to infinity of e raised to power of minus ax squared plus by squared x raised to power 2n minus 1 x raised to power 2n minus 1 y raised to power 2n minus 1 ds dy. We read the multiplication of these two things. 1 gamma of m over 2a raised to power m multiplied by gamma of n over 2b raised to power n. 2b raised to power n, so that it will now be gamma of n over 4a raised to power m b raised to power n. And that is what they want us to prove. That is the answer. That is the answer. So the next thing, to prove now, number 3, we want to solve this one. Integrate from 0 to 1 of ds over square root of minus log x. Ds over square root of minus log x. When the surest thing to do is to let t to be equal to minus log s. You then make s the subject of formula. S will be equal to e raised to power minus t. That is what s would be. So differentiate. ds will be equal to minus e raised to power minus t dt. The next thing to do now is when s is 0. When s is 0, put 0 here. Log 0 is minus infinity multiplied by a negative. T will be infinity. And when s is 1, t will be 0. Put it. You will see what I'm talking about. So this one will now become, when it's 0, don't forget infinity to 0 of ds or 1 over root t. Since I made t to be minus log s, that is t of ds. ds is minus e raised to power minus t dt. So put negative outside to swap the integral. The negative times this negative number multiply by this negative number will give me positive. So this one will eventually, or is still the same thing as integral from 0 to infinity. This 1 over t is t raised to the power of minus 1 over 2. T raised to the power of minus 1 over 2 e raised to the power minus t dt. So by gamma function, this one is exactly, this is gamma function. This is exactly gamma of minus 1 over 2 plus 1, which is gamma of 1 over 2. And the gamma of 1 over 2 is square root of pi. Root pi. That is the answer, root pi. Number 4. Number 4. Number 4, I have integral from 0 to infinity of t raised to the power of minus 3 over 2, open bracket 1 minus t raised to the power of minus t dt. We are told to evaluate and integrate this. What I'm going to use here is integration by parts. I'm going to use integration by parts in this place. I will let u to be 1 minus e raised to the power minus t, and dv to be t raised to the power of minus 3 over 2 dt. By differentiating du, we differentiate this e raised to the power minus t dt. If we differentiate one, you have 0. If you differentiate this one, you have this. Then integrating this one will be t raised to the power of minus 1 over 2 over minus 1 over 2, which will give me minus 2 t raised to the power of minus 1 over 2. If you integrate this is what you are going to obtain. So what will happen next is I will now apply the integral from 0 to infinity of t raised to the power of minus 3 over 2 of 1 minus e raised to the power minus t dt is equal to uv. This is u, 1 minus e raised to the power minus t multiplied by minus 2t raised to the power of minus 1 over 2. Put the bound from 0 to infinity. From 0 to infinity of and then minus integral of v du. The integral of v du, that is integral from 0 to infinity. This is minus 2t raised to the power of 1 over 2 minus 2t raised to the power of 1 over 2 du is e raised to the power minus t dt. E raised to the power minus t dt, that's what I'm going to have. So I have here I have minus 2t raised to the power of minus 1 over 2 1 over e raised to the power minus t, integral from 0 to infinity. Integral from 0 to infinity, and then I will have minus times minus will give me plus. This one will become plus. This is minus. Plus 2 integral from 0 to infinity of t raised to the power of minus 1 over 2 e raised to the power of minus t dt. When you put infinity here, 1 minus e raised to the power negative infinity is 0. 1 minus 0 is 1. But don't forget, this t raised to the power of 1 over 2 of minus 1 over 2 is 1 over square root of t. As this one goes to infinity, this one also goes to 0. So this one will be 0. This one will be 0. When you put 0 here, 0 multiplied by anything will be 0. So in reality, What will be here will be 0 to give me 0 plus 2 integral from 0 to infinity of t raised to the power of 1 over 2 e raised to power minus 3 dt. And this is exactly gamma function of 1 over 2. It's obvious. So, this is what I'm going to find. This is what I'm going to find today. The answer I'm going to get now will be equal to 2 gamma of 1 over 2. And gamma of 1 over 2 is square root of pi. So the answer is 2 root pi. The answer is 2 root pi. The fifth one, number 5. The fifth one is to evaluate. The fifth one is to evaluate the integral from 0 to infinity of t raised to the power of minus 3 over 2. Of that was the last one we did. Of x raised to the power m rather. S raised to the power m e raised to the power minus asn ds. We want to evaluate this and we want to give our answer in gamma function. We want to give our answer in gamma function. So, of course, we can see let t be ax raised to the power n. You will let t to be ax raised to the power n so that you have raised to the power minus t at the end of the day. Make s the subject of formula. So I will have s to be equal to t over a raised to the power of 1 over a. Differentiate. ds will be equal to 1 over n a raised to the power 1 over n t raised to the power 1 over n minus 1 dt. That is what I have done here. That is the answer to this question. What will happen next? When x is 0, t is 0. When x is infinity, t is infinity. So I will have an integral from 0 to infinity. X is this. I have t over a raised to the power m over n now. T over a raised to the power m over n. E raised to the power of minus t. Right? ds is 1 over n a raised to the power 1 over n t raised to the power 1 over n minus 1 dt. This one will become integral from 0 to infinity. This is t raised to the power of m over n. This is t raised to the power of 1 over n minus 1. Law of indices. It will become plus 1 over n minus 1. Right? E raised to the power of minus t. Everything over n. This is a also raised to the power of m over n. Then I also have plus 1 over n dt. That is what I will have. Bring out all the constants. This will give me 1 over n a raised to the power of n plus 1 over n. Then inside the integral, we have integral from 0 to infinity e raised to the power of t raised to the power of n plus n plus n over n rather plus 1 over n minus 1 e raised to the power of negative t e raised to the power of minus t dt. So they are through with what they want us to evaluate. 1 over n a raised to the power of n plus 1 over n. This is gamma of m over n plus 1 over n.